Well, dear students, class 12 review optics. I told you the theory of propagation of light, Huygens theory. I proved the law of reflection, and we find there that the speed of light in denser medium is less than that of rarer medium. Now there is one example, 10.2 shows example of NCERT, 10.2 showed example solved. This is very important question. There are three parts. First part says that when monochromatic light, वैसे तो कोई भी लाइट हो, पर यहाँ मोनोक्रोमेटिक कहा है स्पेशली, just to make you clear. When monochromatic light is incident on surface of separating two media, the reflected and refracted light both have same frequency as incident frequency. Explain why. They have taken here only monochromatic, because the कोई भी light है. Just to understand, actually white light has all colors, from violet to red, and all colors have different frequency. So when any light fall on any surface, it is medium 1, say it is medium 2, so when light is incident, it is reflected, go back and refracted also. But frequency of reflected light as well as reflected is the same white. I told Huygens theory, and I told you that when source of light is placed in medium, then light emitted by source disturbs the particle of medium and they start oscillating with the frequency of source. So they have little twisted the question. The same thing is there. When light fall here, what happens? Many rays are falling. Everywhere the reflection and refraction take place, and this reflection and refraction is due to the interaction of light falling on the surface. Actually, atoms or molecules of the surface start oscillating, and they are forced to vibrate by light falling on them. So it is a case of forced vibration. The molecule may start oscillating with natural frequency. I have explained you meaning of natural frequency. For example, we have pendulum. Its length L and acceleration mg is their mass. So time period of this 2 pi and root L by g, or frequency 1 upon 2 pi under root g by L. So how can we change frequency? By changing length. So this is the natural frequency on length L. This is called natural frequency. Now if we make oscillate it by some external agency, suppose I push my hand with some frequency with this. So that frequency of my hand and natural may not coincide. So initially what will happen? It will start oscillating with its own frequency, and very soon, because of external force applied, damping will take place, natural vibration goes off, and it oscillates with the frequency of oscillating body. So that is case of forced vibration. So here molecules are oscillating due to the incident of light, and these oscillating particles are the source of reflecting as well as refracted wave. since frequency of oscillation of these particles is equal to frequency of wave, so the frequency of reflected light as well as refracted is that of light falling on this. So when any wave travel from one medium to another, so it gets reflected as well as refracted. Both have same frequency. This question is very important, has been asked in the exam also, but people don't take it seriously and keep on telling different answers. KT property. Apply Huygens theory. Huygens theory tells this thing that when particle move, light move in medium, then particle of medium oscillate with the frequency of light falling on them, and those oscillating particles and secondary wavelets. Actually, book has explained, but a very brief explanation is there. I hope you have got my point. You can write it yourself. When wave incident, light incident on any surface, particle medium are forced to vibrate with the frequency of light falling on them, a case of force vibration, and these oscillating particles, whatsoever be charged or uncharged, they are source of reflected as well as refracted light, and hence frequency of reflected light as well as refracted light will be same. Please, dear student, I am telling you, please, if you like my video, certainly you will be liking. If you understand, problem is there, so many problems are there. Sometimes student does not come to the level of teacher. Student does not come to the level of the book. For example, people don't like NCERT book because their level is not up to that now. They want many things. I have seen teacher teaching. I was looking at one video. Teacher was not able to tell what is force. He told types of force, many different type of force, but definition of force was absent from that lecture. So I have made it clear. In book it has been given, but in very brief. I hope you have got my point. Now, second question is also is not properly explained even in NCERT book. It is 10.2 short example. When light travels from rarer to denser medium, the speed decreases. You know, n is equal to c upon c dash. C is the speed of light in vacuum, it is medium. So c dash is equal to c by, so decrease होती है. Does the reduction in speed imply a reduction in the energy carried by light wave? Now, what is the idea of energy here? Again, so when light travels from one medium to another, or wherever it is traveling, whatsoever the medium, then I told you particle of medium oscillate. And please listen me carefully and apply this fact. In class 11 you are told simple harmonic oscillation. The energy, if this particle is oscillating simple harmonically with amplitude A and frequency n, then its total energy is given by 2 pi square n square A square m. M is the mass of body, A is the amplitude of oscillation, n is the frequency. So when light wave, he said the light wave go from rarer to denser medium, so speed decreases. Thus this decrease in speed implies that reduction in energy. Energy of oscillator depend on square of amplitude. Frequency does not change, mass does not change. So when light comes from denser to rarer, Energy decreases because amplitude of vibration decreases. There is no mention of C in this formula. Energy of simple harmonic oscillator does not depend on speed of the wave. Whatsoever the wave, whether it is sound wave, light wave, कोई भी हो, तो reduction in the speed does not imply that energy will decrease. Energy decrease होती है because of change of particle mass and amplitude. So certainly frequency does not change. But decrease in speed of light when go from a denser does not imply the decrease in the energy carried by wave. Energy carried by wave means wave strike the particle medium, they start oscillating. I hope you have got my point. These questions are very important. Just actually basic thing about wave. Third part is there. In wave picture of light, intensity of light is determined by square of amplitude of wave. In wave picture, in the wave model tells that intensity of wave is determined by square of amplitude of wave. Then what determines the intensity of light in photon picture? So first of all, dear friend, I have noticed you don't remember the definition of intensity. What is intensity of wave? I have clearly mentioned and many people have read that. Intensity of wave is the energy transferred per unit time through unit area, unit cross section area, which is at right angle to the direction of propagation. This is the definition. Actually, definition is not written in syllabus. So, teacher don't teach what is intensity. And I told you, as the intensity, if here is point source of power P, and this is the point at distance R. So in this area it will be spreading. So that intensity here is power upon the power energy per second. And further, for mechanical, we have 2 pi square n square a square rho into c. For actually, this thing tell you energy per unit volume into C, that is equal to intensity. So here it depends on amplitude. In case of electromagnetic wave, again I have given you, it is half epsilon 0 E0 square into C. So it is the amplitude of electric field vector which gives the intensity. ये wave model कहता है. Now what is, how to calculate the intensity at any point in photon picture? Actually, Planck quantum theory, which you have learned in, we will teach it further, but in class 11 in chemistry, tell that energy travels in the form of photons. Photon is a bundle of energy, packet of energy, and that photon, energy photon H. So when light is falling here, then photons are falling. Energy of photon, I told you, h nu. depend on frequency as the Planck constant fixed है. So in this term, how to measure intensity means amount of energy falling per unit area per time. So it means energy of photon, one photon is this. So number of photons, number of photons falling per unit time. Per unit time, per unit area is equal to, determines the intensity of light. Larger the amount of energy falling, higher the intensity. Intensity depend on C. तो that second part था ना energy carried. हाँ, intensity decreases when light goes from rarer to denser. तो that intensity तो depend करेगी speed पर. So these are three parts of this question. 10.2 you can read from the book. Now there is one unsolved example. 2 क्या 3 हैं. There are 3 unsolved examples here. 10.1, 10.2, 10.3. So I will tell you something more in next video about the same Huygens theory. Thank you.